Projectiles practice. This is the worksheet that coordinates with the Google form. Google form basically just gets you a place to input your answers. All right. Pelican flying along a horizontal path drops a fish from a height of 7.4 meters. The fish travels 8.0 meters horizontally until it hits the water below. How long did the fish fall until it hit the water? So 7.4 meters measures displacement. 8.0 meters measures displacement. It is falling. It's been dropped. So we have a 0 meters per second vertical initial velocity. It has it's falling, so we have negative 9.81 gravity, and the question is asking us to solve for how long did the fish fall. So how long did it fall is actually a question of time. So looking at our formulas, 7.4 is the height of the fish, so that's my vertical, delta xy. The fish travels 8 meters horizontally, so this is my delta xx. Choosing your formula, we need to solve for time. We have 3 formulas here in orange that solve for time. This one requires initial and final velocity. I don't have those. I have an initial velocity vertically, okay, but I don't have a final velocity. This one needs horizontal velocity. I don't have horizontal velocity, so I just have initial vertical velocity. This one needs vertical displacement, and I do have vertical displacement, so we're going to go with that one. So square root of 2 times the vertical displacement divided by gravity. Now that vertical displacement is technically negative 7.4 because it's falling, and gravity is a negative 9.8, and negative divided by negative gives you positive. So you can put these numbers in negative, or you can just make them positive. It gives you the same answer, but you can't square root a negative number. So 2 multiplied by 7.4 divided by 9.81. Again, I'm making this positive just to simplify. Otherwise, I have to make them both negative. Negative divided by negative gives me a positive. Type that into the calculator. Typing that into the calculator. So we get our square root. Type it all in at once. 2 multiplied by negative 7.4 divided by negative 9.8. 1 for sig figs. Calculator reads 1.22827 sig figs. We just need 2 significant figures to give 2 sig figs in our measurements. So 2 significant figures gives us 1.2, solving for time, so this is seconds. When you type your answer into the computer, make sure that you put a space there between the 2 and the S. All right, next part. Pelican flying a horizontal path drops the fish. Exact same scenario with pelican. So we have the 7.4 meters is our vertical displacement, 8.0 meters is our horizontal displacement, 0 meters per second squared is our initial vertical velocity, negative 9.81 for gravity, and now we can transfer this time of 1.2 seconds over here. So 1.2 seconds is our time. Question is asking us to solve for the pelican's initial speed. So that initial speed, the pelican initially is moving horizontally. So this is a horizontal velocity we're trying to solve for. So we want to solve for horizontal velocity. Even if you weren't quite sure, you'd be like, okay, velocity, trying to solve for velocity. Which velocity are we solving for? Well, we have horizontal displacement and we've got time. Gravity is involved, but we're dealing with the horizontal movement of the pelican, so we want the horizontal velocity. And that is the horizontal displacement divided by the time. So plugging our numbers in, horizontal displacement of 8.0 0.0 meters, my horizontal, not my vertical, but my horizontal displacement, meters, and 1.2 seconds. Type that into the calculator. Calculator says 6.66667, 2 sig figs because we've got 2 in our measurements, so 6.7, and I'm solving for velocity. My units of measure are meters per second. Again, be sure to put a space in there after the 7, between the 7 and the M when you put your answer in the Google form. All right. We now have Abby. We have a 208 meter tall cliff. So that is displacement because that's how tall the cliff is. That's vertical displacement. We have 62.8 meters per second. That's how far she was driving her car until it went off the cliff. So that is a velocity horizontally. And we have gravity. Okay, negative 9.81. And we also have an initial vertical velocity of 0. Question is asking for how long was Abby's car in the air. Question is asking for time. So we're solving for time. Formulas to choose from. We can either use, we have final initial velocities or horizontal displacement, horizontal velocity, or vertical displacement and gravity. Well, we have vertical displacement and gravity, so this is the formula we're using. Square root 2 vertical displacement over gravity. Again, this formula we're using, make sure that we have our numbers, either make both your numbers positive or make them both negative, so that our numbers work out, so the calculator doesn't give us an error. So 2 multiplied by our 208 over a positive gravity to give our numbers easy. Punch that into the calculator, so we have square root of 2 multiplied by 208 divided by 9.81. Calculator says 6.5119. Sig figs, I've got 3 in both of those numbers, so 3 significant figures in our answer. So 6.51. Units of measure, I'm solving for time, so this is seconds. Okay, so next we have the same Abby running her car off the cliff. Okay, so our same variables. And I can bring the time from the previous question. 6.51 seconds is my change in time. Okay, so question is asking us to solve for how far from the base of the cliff will her car hit. So we have a projectile off of a cliff. The question is asking when it lands, how far has it moved horizontally? So we want displacement, horizontal displacement is what the question is asking us to solve for. Horizontal displacement. So horizontal displacement is the question. Which formula am I going to use? Now, if you were just looking at displacement, you got both of these displacement formulas, like, well, which one's which? Well, this one has velocity and time, and this one has gravity. Gravity means this is going to be the vertical. Gravity means we've got vertical, no gravity, horizontal. So our no gravity, horizontal version of the formula is what we want. Do we have the information? Do we have the horizontal velocity? Do we have the time? Well, there's a horizontal velocity, there's a time. So yes, we have what we need. Horizontal velocity is 62.8 meters per second. I'm going to multiply that by a time of 6.51 seconds. Make sure you include those significant figures, otherwise you'll probably get the wrong answer. Calculator says 408.828 significant figures, 3 significant figures, because we got 3 digits in all of our numbers. So we have 409 displacement meters. Okay, saying now we have Pete jumping off a cliff. 3.21 meters per second is a velocity. 19.7 meters is a displacement. We've got driving off of a cliff, so we have gravity. And we've got, since he's jumping horizontally off that cliff, we've got initial vertical velocity of 0. And the question is asking us to solve for how long is Pete in the air? Time. Okay, so let's go back to this speed at 3.21 meters per second. That's his running speed, so that's his horizontal speed. And this 19.7 meters, so lands in the water 19.7 meters from the base of the cliff. So again, that one is from the base of the cliff. That's horizontal displacement. So that one is my horizontal delta XX, horizontal displacement. So I'm trying to solve for time. I need a formula that solves for time. So I either have this one, final initial velocity over gravity. I've got horizontal displacement over horizontal displacement over horizontal velocity, or vertical displacement. I don't even have vertical displacement. And so it's going to be this one, because I have my horizontal displacement and I have my horizontal velocity. So this is the formula I'm going to use. So plug in my numbers. The displacement of 19.7 meters over velocity of 3.21 meters per second. divided by 3.21. Calculator says 6.13707. Significant figures. We need 3 sig figs, so the 6, the 1, the 3. This 7 is going to round that 3 up to 4, so 6.14. Solving for time in seconds. We are still working with Pete, so we are going to get all that information from the front side. So we have that 3.21 meters per second, which was my horizontal velocity, the 19.7 meters, which was my horizontal displacement, gravity, which is negative 9.81, 0 meters per second for my initial vertical velocity, and I solved for the time it was in the air, which is, he was in the air, which was 6.14 seconds. And here's your formula. So I need to know what I'm looking for. How tall is the cliff? How tall displacement vertically? So vertical displacement is what we want to solve for. Displacement vertically. Gravity is involved, so this is a vertical formula for vertical. This one's no gravity. This one does have gravity, so this is the one we want. 1/2 gravity times squared. Plugging in our numbers. 0.5 multiplied by negative 9.81 multiplied by the time, which was the 6.14 squared. Order of operations, that's that 6.14 gets squared, then you multiply by the negative 9.81 and then multiply by the 0.5. Okay, so 0.5 times 9.81 multiplied by 6.14 squared. You can type it all into the calculator all at once. Your calculator knows order of operations, and will do it correctly. Calculator says a negative 184.917. All right, so how tall is the cliff? The fact that it's asking for how tall, that implies a positive number. If it said how far down it fell, which is asking the same thing, it would be negative. So we're going to actually make this positive. So 180, 3 sig figs, 185, and that displacement is in meters, 185 meters tall. That's the height of your cliff. All right, we have a new scenario, the cat, 0.329 meters per second. That is the velocity with which the flower pot was hit. So basically the cat bumped into it ever so slightly. So that's a velocity. That is a horizontal velocity of the pot as it falls. 5.97 meters is again that distance it traveled horizontally, the pot. Okay, how far is away from the building? So that is a horizontal displacement. Gravity 9.81, and initial vertical velocity is 0. Question is asking for time. How long did it fall? Formulas for time. We know the horizontal velocity and the horizontal displacement and gravity and initial velocity. So we know initial but not final. We do not know the vertical displacement, but we do know horizontal displacement and horizontal velocity. So we're going to use this formula right here. Okay, plugging in our numbers. Horizontal velocity, displacement, 5.97 meters divided by the velocity, 0.329 meters. So 5.97 multiplied by, divided by, sorry. 5.97 divided by 0.329. Calculator says 18.146. Okay. Significant figures in our answer. We need 3 sig figs. We've got 3 sig figs in our original numbers. So 18.1. Solving for time in seconds. Now, 18.1 seconds is actually a really long time for something to fall. So, fair warning. All right, so we still are working with the same cat knocking the flower pot. So we still have the same information. The difference is now we can add that 18.1 seconds to our known information. So we have 18.1 seconds for time. Question is asking us to solve for how high up is the window? How high up? Vertical displacement. So vertical displacement formulas. We know it's vertical because gravity is involved because we're going up. How high up was it? Okay, so 1/2 GT squared. So plug in my numbers. 0.5 multiplied by gravity, 9.81. We're going to keep this positive in the end, but I'll put it in negative for now. Time of 18.1 seconds, and that time needs to be squared. Now, this is going to give you a very big number. Don't freak out too much from it. Calculator gives us a negative 106.927. So 1,600 feet. Yeah, actually, meters. Actually, yeah, that actually makes sense. Because falling for 18 seconds is a really long time. This is a really tall building. It's like on the 24th floor. Whatever. Here we go. So significant figures, we're going to make this positive because it's asking how high up, so it's going to be a positive displacement. And significant figures, we need 3 significant figures. Not sure if I put that right in the calculator, in the Google form. 1610 has 3 significant figures. Yeah, I think I did that right. 1,610 is this number rounded to just 3 sig figs. And we're dealing with displacement, so that's meters. If you write down 1,607, that's 4 sig figs, it would be marked wrong. Okay, last scenario is the ball rolling off the table. 98.7 centimeter tall table, that's displacement vertically. 39.1 centimeters is the distance away from the table, so that's my horizontal. And we've got gravity, and we've got initial vertical velocity of 0. And the question is asking us to solve for how long was the ball in the air. So solving for time, when all you know are your 2 displacements, your vertical and your horizontal displacement. We have here time, 3 formulas to choose from. This one has vertical displacement and gravity, so this is the one we're going to use, the one we have variables for. Square root 2 delta xy over g. Plug in your number. Same formula we've been using 1,000 times. 2 multiplied by. Now, pause. Look at your numbers. Consider your units of measure. Do we put centimeters into formulas? No. We gotta turn that into meters. So, 98.7 centimeters. I asked this question twice already, so you should already know that they need to be converted to meters, so it's going to be 0.987 meters over negative 9.81 for gravity. Make it positive, just so that we can deal with positive numbers. And plug in your calculator. Square root. Square root 2 times 0.987 divided by 9.81. Keep gravity positive just to make all numbers easier. Calculator says 0.448579 significant figures. We need 3 significant figures in our answer. So 0.449, and we're solving for time, so that's seconds. All right. Next, we have the same ball rolling off the table, so we have the same variables. So 0.987 meters vertical displacement, 0.391 meters horizontal displacement, gravity, initial velocity of vertical velocity of 0, time, we've got the 0.449 seconds. That's our time. So the question is asking us to solve for how fast was it rolling? Velocity. It was rolling across the table, so that is a horizontal velocity. We want horizontal velocity. We need the horizontal displacement divided by the horizontal to have a time. So horizontal displacement divided by time. Plug in your numbers. So horizontal displacement was the 0.391, time of 0.449 seconds. Some small numbers there. 0.391 divided by 0.449. Calculator reads 0.87082 sig figs. We need 3 significant figures in our answer. Dot dot dot. That 8's gonna round that 0 up to a 1, so 0.871. Velocity. This was meters. This was seconds. Meters per second. Oh shoot! I didn't show the last part. There we go. Meters per second. And there you go.